that's pretty radical. That I think is true. We can argue about it. In other words, pests and diseases are organisms that love and prosper in enriched environment. So when you fertilize and enrich something, then you encourage things that grow fast. Our ecological language here is R and R selection and K selection. In other words, in the early growth system, the species that grow fast and have lots of young are in control. Then when you get the full up system, then the K-selected species that where the survival depends on the survival of the individual rather than the amount of young. And so we go from R to K selection, you see, then we have to realize that this means a different lifestyle, and we haven't learned. Most in nature, very few species can go. Early successional species like a weed cannot survive to the climax. It doesn't survive in the forest, and so we have to learn as one species how to survive from R to K, from a period when high reproduction, big families, and all are very important for survival. You don't survive in the pioneer world. You don't survive in undeveloped countries without a big bunch of kids to do all the child labor that you have to do. And so when you get to the full-up society, then individual equality and individual survival, big oak tree doesn't produce a whole lot of acorns, really. The small amount of its energy goes to that, just enough to keep the species going. It does not produce surplus in that thing. And so we have that. Another one of the most interesting examples recently of this enrichment thing, and I've gotten a little. I don't think anybody's really written on this. I'll say maybe I'm the first one to point this out. I did have a commentary on this in the Bulletin of the Ecological Society recently, but every day some interesting example comes up. The red tide, of course, is a good example. The red tide is an organism in estuaries that produces a little poison to keep predators off, and normally it doesn't do any harm. But when you eutrophication it, that species loves enrichment, and then it produces too much, and then there's too much poison, it kills all the fish. And then an even more example is cattle. You find out that when you put cattle in feedlots and overfeed them, enrich them, first thing you do, of course, you cut out the cattle's beautiful adaptation to take dry hay and the rumen, you see, and convert it into human food. And when you feed them corn, that's the stupidest thing you can do, because you are now feeding high quality food that could better go to people. And you cut it, and when you feed them corn, the whole beautiful microbial system is shut out, because it doesn't need now, you see, to convert cellulose into something that can be digested. And so they found out that these cattle in feedlots were getting a lot of special diseases, and the meat was getting contaminated with these diseases. And they found as soon as they took the cattle out and put them on grass again, they disappeared. And so one of the prices we pay, you see, for trying to get more fatty meat by eutrophicating cows. And people don't think about that as being eutrophication, but it's the same thing, enriching. And so enrichment is good up to a point, but like everything else, we suffer from too much enrichment. So we have lots of good examples. I've got a whole bunch of them here. This virulent E. coli is what turned up, and there was a big article on that inside. Okay, to continue then with this, how systems behavior, you see, if you consider behavior as how it functions, behavior then is, you see, a transcending function. We can talk about the behavior of the individual, which we do, and psychology, the behavior of people, ethics and so on. But behavior systems behave too, and their behavior can change, and their behavior does change with size. And so the fourth thing I have here is that maintenance costs increase as a power function of the increase in size. This is something that's been in textbooks and articles for years, and yet I would say that 90% of people that don't realize. When a city doubles in size, for instance, it costs more than double to maintain it. It costs to keeping things from coming apart pumping out the disorder, is the way my brother puts it. In other words, the energy it takes to pump out the disorder of complex, large systems like crime control and traffic control and pollution control. This increases faster, so that if you want to double something, you're going to have to be able to pay, and your taxes have to go up. In spite of all the tax relief people hollering about, the bigger you are, the more taxes you have to pay, because taxes pay for all the services and all the things that keep things from going apart, and so on. So that in succession and climax, the PR ratio is an important thing. And to us, to me, the way to say when you have enough is when the R, which is maintenance, in other words, P is the production, the amount of energy that can, in case of a forest, the amount of energy you can get from the sun, or in case of humans, the amount of energy you can get from the oil and other stuff that it brings in. In a young growing system, most of that goes to growth. So what the kid eats, you see, he doesn't eat a whole lot, but most of what he eats goes into growing. When we eat, it goes into maintenance. If we eat too much, you see, then we get in trouble by having the growth when we don't want it. And so the whole thing here is that, to me, the sustainability, which is a hard word to define, is best thought of in terms of PR ratios, a basic ecological principle as you go from pioneer to mature ecological succession, which, I've always wanted to call ecosystem development, because it's not a passive thing. It's not that the species succeed one another. It's the whole metabolism changes. And we should think of the climax not in terms of species, because that varies all over the place, but just in terms of the balance in the metabolism between production and respiration, the respiration being maintenance. So PR is the ratio of income, energy, and the amount of that required. The old forest, everything you can get from the sun is made just to keep the thing from coming apart. There's the big trees have to have a whole lot of energy just to protect themselves and to maintain their structure. And so when we get, the ultimate limitation then is, let's put it this way, you cannot have a viable system if the cost of maintaining it is greater than what you can pay. New York has been that way for years. It only exists because we subsidize it from outside. All the government extra, we put money to keep New York from coming completely apart. Can't possibly maintain itself with all that infrastructure and so on. And all big cities then are parasites, you see. And as long as we have extra energy and so on, we can do that. Okay, now the fifth one here, and I just got two more. Fifth one here is that mutualism increases with ecosystem development, complexity, and nutrient scarcity. The vignette here is when things get tough, it pays to cooperate. And so as we go from early stages in succession, competition dominates it. And most ecologists think competition is the only thing. Several years ago, one author took 10 textbooks, including mine, and they had his secretary count the number of pages devoted to competition, predation, and mutualism. And most textbooks produce, say, 300 pages on competition and maybe 20 pages on mutualism. And my book was the only one at that time, that was several years ago, that had equal amount of pages for mutualism as for competition. And so it's not whether, if, it's when. It's at what stage of the development of a system do these dominate. And in the early stages and in the pioneer stages, and we here in a pioneer country, we still think competition is everything. Every business should try to knock every other business out, and competition makes things go and so forth. So we're in the avenue, and that's true. But when we get to the mature stage, as much of Europe is, then we're working together, like the euro, trying to make one currency in Europe. This is something that you have to do sooner or later. And